Hey, thanks for clicking the start button on this video about subatomic particles. If you want to follow along, there's a link to the blog, the companion blog, down in the comments. But in this video, I've got a couple students who are going to go over some of the definitions and some of the descriptions of subatomic particles. Hope you enjoy it.
So this is on subatomic particle configuration. As understanding of atoms increased, different experience resulted in the discovery of particles of which the atom is made. Thomson is credited with the first realizing of that the atom is made of particles, some negatively charged and some positively charged. Rutherford was credited with identifying that the positive charge is located within a central, relatively dense nucleus. Later, in 1932, James Chadwick designed an experiment to show that neutrally charged particles also existed in atoms, neutrons. To summarize the development of atomic metals, the modern atom is understood to be made up of subatomic particles. And then, so the proton is a positively charged subatomic particle that is found in the nucleus of an atom. The symbol is P+, it's 1 positive, the mass is 1, and then the actual mass is 1.674 to 10 to the power negative 24, and then the location is in the nucleus.
An electron is a negatively charged particle found in the outside of the nucleus. Its symbol is E with minus, and then the relative charge is -1. The mass is 1/1836. Its actual mass is 9.11 times 10 to the negative 28th power, and it's found in distinct orbitals surrounding the nucleus.
Neutron is a neutral subatomic particle that is found in the nucleus. The symbol is N, the relative charge is 0, the relative mass is 1, the actual mass is 1.675 times 10 to the power of negative 24, and the location is in the nucleus.
For the information above, a few conclusions. Protons and neutrons are almost identical in mass. Electrons are about 1 and 2,000th the mass of a proton. The neutron does not affect the charge of an atom, they just add mass.
It is the unique ratio of the combination of subatomic particles that in different atoms they give different elements and characteristics. Through all the elements are built out of the same subatomic particles, protons, neutrons, and electrons. The many different combinations possible result in the many different elements that can be observed in the creation.
The basic classification system for elements in the periodic table. The rules that identify exactly what we call a sample of an element is based on the configuration of atoms which make it up.
The atomic number is the basic classification is based on the number of protons. The number of protons in the atom is called its atomic number. Atoms of the different elements all have different numbers of protons and thus different atomic numbers. If an atom has 1 proton, it is hydrogen. If it has 6, it is carbon. No matter what else happens, the number of protons determines its atomic number, and atomic number determines the type of atom.
Another very important difference among atoms is its mass. The mass of a number is the sum of all masses of all the protons and neutrons in the nucleus of an atom. Not all elements have equal numbers of protons and neutrons. So to find how many neutrons are in an atom, you take the mass number minus the atomic number.
For example, the atomic number of chlorine is 17 and its mass number is 35.45. Subtracting it, it becomes apparent that there are 18 neutrons. You would ignore the decimals in the process.
The mass number also tells us how many grams 1 mole of atoms would weigh. Looking at the periodic table, we know how many grams of something would be needed in order to have 1 mole of it. Doing math, we can therefore calculate the mass of any fraction of a mole of any element. So 1/10 of a mole of sodium would weigh 2.299 grams.
So isotopes is a number of protons in an atom that determine what the element is, but in some cases it is possible to add neutron to the nucleus, which would change its atomic weight. For instance, a neutron could be added to hydrogen given its mass around 2, yet only 1 proton. It would still be hydrogen, the atomic number 1. Atoms with the same number of protons but different numbers of neutrons are called isotopes. Isotopes of an element have the same atomic number but different mass numbers because they're different with the number of neutrons.
Understanding just the 3 previous ideas, any substance can be classified and fit into the periodic table as either an element or an isotope of an element. Understanding these concepts open the door to working with elements in vast and complex ways.
Okay, let me throw a couple of questions out. So move over that way. A couple of things that the atomic number is what? The atomic number is the number of protons in the atom. So if an atom has 6 protons, what's the atomic number? 6. Okay. If an atom has an atomic number of 12, how many protons are there? 12. Exactly the same number, right? So the atomic number and the number of protons are always the same. If you change the number of protons, you change the element. If you change the number of protons, the element changes. So if you have 19 protons and you add another one, it stops being potassium and starts becoming calcium. Okay? So adding protons changes the element. Adding neutrons changes the mass, but not the atomic number. So if you have iron, if you have iron that has an atomic number of 26 and 56 is the mass, how many neutrons are in there? 30. There will be 30 neutrons. If you throw another neutron in, it's still iron, but it's going to have a larger mass, and that's going to make it an isotope. If you throw another proton in, theoretically, if that were possible, it would become cobalt, and it would no longer be iron. So adding neutrons changes the isotope. Adding protons changes the element. Completely changes the element. Does that make sense? Okay. If you add a neutron, it's an isotope change. Or if you take a neutron out, like we have carbon, which is generally carbon-12. So carbon-14 is an isotope of carbon. Okay. If you add a proton to carbon, it's going to become something else. It's going to become nitrogen. So if you add a proton to carbon, it becomes nitrogen. If you add neutrons, it's an isotope of carbon. So that's how isotopes and that thing works, okay? Does that make sense? Yeah. You guys have anything else to say? Any questions for our guest experts?
No. Good job.
Are you really experts?
Yes, I'm certified.
All right.
Let me see your license.
I like how that's on recording.
It's all recorded.
It's recording.